Hi guys, I'm here in my nursery. I'm going to show you how to do Boyle's Law lab, or just Boyle's Law calculations. The equations for all three that we're doing today, Boyle's, Charles, and Guy-Lussac, are pretty easy. The hardest part is going to be figuring out the variables. So you can see over on my screen here, I did a little labeling of the variables we're going to use. It's P1 times V1 equals P2 times V2. So what we want to do when we read the problem is look for units that will match either pressure or volume. And if you look back at page 5 of your packet, the charts have some units for pressure and temperature here. And then for volume, we're looking for units like liters or milliliters usually. So in this example problem, we only see two numbers. They're both in liters. So they're both volumes. I'm going to put V's over those. The third number that we need to complete this calculation comes from STP. So STP will get snuck into these calculations that will give you either temperature or pressure. So STP stands for standard temperature and pressure. So in this one, it doesn't say what units to use. If I have the choice, I always pick atmospheres because 1 atmosphere is STP and everything's close to 1. So for our pressure, it can be any unit at STP. The example I'm going to do in atmospheres. So we have 3 sig figs for the other number, so I'll do 1.00 for this one. But you could also, if you look at your chart back on page 5, at STP, we also have 760 millimeters of mercury, 760 torr, or 101.1 kPa. Those are the same thing. But you got to pick one. Whatever unit you use for pressure before, that one will be the same one after. So with these, what we want to notice is that these two are at the same time. So 7.6 liters at STP when the pressure is 1.00. These two belong on the same side of the equation. So what you call 1 and 2 doesn't matter as long as the ones that are at the same time are on the same side of the equation. So I'm going to say that these are 1 because it said occupied. So these were like the initial conditions. But if you call that P2 and V2, that's fine as well. So P1 is the STP pressure, which is 1.00 atmospheres. And V1 is our 7.60 liters. P2 is what we don't know, so I'll just put a question mark. We'll leave that as a variable in the calculation. And then V2 is the 10.0 liters. So these numbers are going to get plugged in for the equation. So I'm going to rewrite the equation here. You don't have to. P1 times V1 equals P2 times V2. So this stuff over here on the left, if that doesn't look helpful for you and you just want to go right to plugging in the numbers, that's fine. But a lot of people find this helpful for keeping track of their numbers and what they have. So P1 times V1, we plug in the numbers. I'll write the units here. Equals, for P2, I'll just leave it as P2, that's what we're solving for, times 10 liters. And then now that we have all the numbers plugged in, it's just an algebra problem. So we're trying to find P2 by itself. P2 times 10 equals the other side. So we're just going to divide by 10 on both sides. Pretty easy algebra. So this one you can actually do in your head without a calculator because 1 times 7.6 is 7.6. And then dividing that by 10 gives you 0.76. We had 3 sig figs, so I'm going to keep 3 sig figs in the answer. With these, I will be pretty lenient on sig figs. Usually it'll be 2 or 3. So that's your final answer. Whoops, sorry, that's not liters.
The liters will cancel out. Whatever pressure unit you had on the one side, it'll be the same on the other one. So this one will be atmospheres. And that is P2, our second pressure. Look at my bad girl. Hi, Zenny. All right. So if you were to calculate V, it would be the same thing. Same idea. They're just multiplied together. So I only gave you one example problem. But that's it. Plug in 3 numbers, solve for the fourth, and that's how you're going to solve a Boyle's law equation.